Hi everybody, last conference for today. I'm proud to welcome Nicolas Grekas on scene, and he's gonna talk to us about Symfony Runtime. Nicolas.
Do I need to put the mic? Okay. Hello everyone. I'm happy to be on stage in real life. I think that's the case for every speaker today. So I'm going to tell you about Symfony Runtime for like 40 minutes. And which is basically a way to put a PHP application in a box. And the PHP application can be, of course, API platform. And that links up very well with Kevin's talk about edge computing and things like that, because this is where you might want to use that. So Symfony Runtime is a COVID lockdown artifact. I was bored almost 1 year ago, a Sunday. It was sunny, and we weren't allowed to go outside. And so I started this day looking at that. So this is the hello world in PHP. It's a more advanced hello world because it's reading some global variable to display the request URI, right? So if you look at this, it's basic PHP, is very low level. We just bootstrap the PHP engine. There is nothing, there is no autoloader, there is no classes, there is absolutely nothing. And this has a drawback. This drawback is that it relies on super globals, like we read some magic variable that is in the air, and it's not reusable. It's very difficult to run that in a loop in a different style than executing it from the PHP runtime directly, the typical way to run PHP scripts, right? And we still run Symfony applications this way. This is how the front controller works. It starts from nothing and it builds up a Symfony execution environment, right? And we usually forget about that, but that's how the PHP world starts. So I started this day saying, okay, there are drawbacks to that, and I'd like to be able to do that, actually. I'd like to be able to return a closure and say, now instead of relying on the super global, this closure is going to take an argument, which can come from anywhere, not a magic variable. And then I'm relying there on some outside execution runtime that should know what to do with the closure, right? So that's how I started that. And there are some challenges there, but the benefits are, this is now decoupled from the global state, right? You saw that, there is no magic anymore. You can decorate that. So now there's something that is going to run the closure. And this something can do something before, after, like do some instrumentation, what you want, basically. So we can decorate and change the behavior of the runtime environment. And then we can also run that many times because we have a closure, and a closure is a function, so you can call it once, twice, as many times as you want. It's built in a box, and this box is the reusability unit, like a functional unit. So I went one more step, and then I said, okay, what about that? Can we make that work? Like, this should be our front controller. We open a PHP file, it's empty, and we write that, and can we make this work? So there you can see there is still the closure, but now it takes an argument, which is a Symfony request, and it returns a response, right? So we should find a way, I wanted to find a way to make this work. There are challenges on the path, and it would be nice to be able to not have to care about creating a Symfony request on our own, because this is a process that is coupled to something like the infrastructure that we don't want to care about. We want to decouple our applications from the infrastructure. So there are challenges. The one is, how do we get the return value from a script? If you think about that, it's not built in the PHP engine. When you return something from the front controller, the return value is just ignored. It disappears in the air. Then there are arguments. So the Symfony request. How do you create that? How do you resolve the arguments? So another challenge. So it was a funny Sunday. How do you deal with the return value? Now you run the closure, you get something back. Oh, it's a response. What should I do with that, right? How do we make that extensible? That's also the next step. How do we build a software design that solves all those challenges in some extensible way so that this is reusable and not hard-coded logic. So I published, not Truck Bootstrapper, that was my prototype. I published, we published actually the runtime component this winter, and new applications since this winter use the Symfony Runtime to bootstrap. So if you create a new Symfony project, you will have the runtime component, and it will be responsible for starting from the very beginning and wrapping the Symfony application in the box. So the goal, kind of the catchphrase of this component is, its goal is to decouple the application from the global state, which is kind of abstract sentence, right? So what's the global state? This is typically, so a code, like a PHP script, it needs some environment. So this is the house, and the house, your application is run inside this house, and there are some things, variables, that are floating in the air, and you can read them, you can mutate them even. So this is our runtime execution environment. And if you look there, this is the front controller, the typical one. There are many places in the code that read from the global state, like the .env line, we read from the file system, the configuration for debugging, the configuration of the kernel, and the request is then also created from globals. This is even worse because this is hidden in some static method. So, wow, where does this come from? It's magic, right? That's how PHP works on this topic. So now, what if we put our application in a box so that there is some kind of well-defined communication protocol, like the closure, that wraps our application so that we can then maybe change the runtime, right? Because this is, the previous script is tightly coupled to PHP and the way it actually exactly runs and populates superglobals and etc. So this is what the runtime application, the runtime component is about. It's about wrapping our applications in this box to decouple them from the outside. So this is a short example. I have a few in the next slide so that you can figure out, maybe get some understanding of what this does. So this is a script. If you look there, it's a closure. There's the autoloader at the beginning. Then we have this closure that does some thing with the request, and we run the application at the end. So this script has the same drawbacks as the first one, the hello world, because it is tightly coupling the functional unit, like the closure, and its execution. You cannot get only the functional unit without executing it, and that's tight coupling. We might want to decorate or to do something fancy with app before running it, or running it many times. So to fix that and to make it run using the Symfony Runtime component, we changed the autoloader. So the autoloader is now a vendor autoload runtime. That's something that is going to be generated by the component. We wrap this closure into a closure, and we return the closure, right? So we have two closures. One is the functional unit to ship that and to return something useful to the outside. And then the outside will get this closure so that this runtime thing that is the context outside the runtime execution engine is going to be able to call the closure somewhere else. And we don't care there. That's the point. We do not care about the infrastructure, about how this works. We just declared that. There's something missing, of course. It's the context variable there. We need to reference the local variable instead of the global one. So I hope that was okay, that you understand the step we made together. Let's do that with the Symfony index.php file, the one I showed before. So there it is. So I told you there is one thing to do. We replace autoload by autoload runtime. This is the thing that is going to be able to catch the return value, right? There is something I'm going to explain you how it's going to work just after. So what is globals there? The .env file, this is global state. We remove that. Configuring the debug mode, this is global state. We remove that. Creating the request after the kernel, this is global state. We don't want that. And then also the end. The end is not something that is specific to our application. The end is the only way to deal with a Symfony kernel, right? So if we have a kernel, something this outside, like the Symfony Runtime component, should be able to run the kernel. So we remove that also, the terminate too, and we are left with a kernel, which is the thing that defines our application. So then we wrap that into a closure. We change the super global and we make it a local variable. We indent, and that's it. So that's the new front controller of Symfony 5.3 applications and the next versions too. And that's the only thing you need to do to bootstrap a Symfony application, because the runtime component is then going to be able to make that run and basically run all the code that has been removed. Now it's moved outside. And that was the motivation for creating the component. So I'm telling you about benefits like theoretical or design and things like that. My benefit, the benefit I had and the motivation was, let me go back. This is a script that was shipped by a Symfony recipe. So that's something that is committed into your Symfony application. But we want to be able to upgrade that. This is not the same script 5 years ago. This was a bit different. And it's difficult to update. You have to figure out the changes, because this is not in the vendor directory. So we don't have control over that. Now, if we move those lines in the vendor directory, in the runtime component, then it's much easier for us to maintain that for you. So that was my motivation. So why do we do that? So this is your application like the one before in PHP-FPM or some Apache model. But you might want also to run the Symfony application in a Bref context. So Bref is this wrapper to make PHP code run on AWS in a Lambda, right? So your application needs to be rewritten. At least the bootstrap process needs to be rewritten right now to run there. Or maybe you want to run your application in a Swoole server context. So this is again very different, because now this is a C extension where you have a long running process. So you need also to hook into the way Swoole provides you, gives you the responses and how you can communicate with the outside world. So there is again some code, some glue to write between your Symfony application and the Swoole execution engine. So now if you put your application in this box, this closure, we can decouple completely your application and make the infrastructure swappable. That's also the benefit. Now, the same application, the one we had before, basically any Symfony application starting from 5.3, is very easy to run in Swoole or PHP-FPM or etc. There are many runtimes. I mentioned Bref, I mentioned Swoole, there are others. And Tobias Nyholm, I'm sure you've seen his name because he maintains so many packages in the PHP ecosystem. When he saw the component, he said, oh, I need to create an organization for that and to put or to publish many runtimes. So if you go there, you'll see he wrote many runtimes, and that's how you can make use of that very easily. So he wrote that. If you go into some empty directory, you composer require runtime Swoole. So let's do that. So seeing is believing, right? So we are doing that, and this is something you can do just after the talk. You will need the Swoole extension, but that's something you'll find easily. And then the same public index PHP file I showed you before can be run this way. So this is configuring through an environment variable the actual runtime we want for running this script, right? And that's it. Because we have the Swoole, the runtime Swoole package, this variable will be read by Symfony, and it will be able to select the correct piece of logic to run this application on Swoole. That's for production, maybe, because you want super high performance. But on the local development machine, you might want to use PHP-S, like the local web development server, because this is more convenient, because there is this auto-refresh mechanism so that you change a class and you don't have to stop the server and start it again, right? So same code, different runtimes, different experience, each tailored to the need or to the actual use case. There is a benefit also, which is leveraging Swoole, and Swoole is super fast. So this is Tobias telling us that if you run Symfony in a loop, like in Swoole, you'll get a 50 performance boost. This is because the container and the kernel won't have to be restarted again and again for every single request. So you will save that. He also ran that on Laravel, and he has like a 100 times boost. This is because Laravel is slower, because it's not compiled. So if you save a slower thing, you have a higher ratio. So this is basically saying that Laravel is faster than, or Symfony is faster than Laravel for the boot time, and then we don't care because usually your application runs, right? So how does it work under the hood? The challenges I mentioned. So let's see that. So let's create a PSR example. This is also to tell you that Symfony Runtime is about running PHP applications in a box. It's not about running Symfony application, right? So this works. This is a PSR example. I don't like PSRs, but I like showing you that this still works. PSR 7 at least. So this is another runtime, the PSR Neon runtime, and this one is able to create PSR 7 objects from the PSR 7 Neon library. So we do that. We open an index.php file there where we can put that. So here, if you read that, it's one file, but you could split that in two files, right? One to declare the class. So we have a very simple class, and this class implements a request handler interface. That's the important thing. We implement the handle method from the interface, and there we do something like returning a response, which is the contract of the request handler interface. And then what we do, and the box we give to the runtime component is the application. So we return the application from the closure. And the runtime PSR Neon component is going to make that run. So this works. We didn't have to care about creating the request itself. That's the point. So let's see what a runtime is. So this is the code, an excerpt of the code to declare and to create a runtime. So there you see we have a PSR 15 runtime. This is the thing that is going to know how to deal with a request handler interface. And you see there is, we extend generic runtime, and we have this get runner method that is going to return a runner. And there you see, if it's a request handler interface, like our application is, then this runtime knows what to do with that. So it's going to return a new PSR 15 runner that is wrapping the application. And if not, we're going to fall back to the parent class, and the parent class is going to know how to run a Symfony kernel, for example. So then you can have one runtime that runs either PSR 7 application or Symfony application or many. You don't need to care because the runtime will select automatically the most appropriate logic to make that run. So this is the runner. The runner does one thing, which is calling the handle method, you see at the bottom. And from the response there is going to run the response, which in this context means echoing the body. Of course, this works as an Apache model. You would have a very different logic to run, so the runner would be different to run on Swoole, but your application wouldn't care. That's the point. So this is the HTTP kernel runner. So we are back in the Symfony world. There you see, we have the kernel, we call the handle method, then we send the response that we've got back, and if the kernel is terminable, then we terminate it. So basically, that's the lines of code, the last lines of code we have in the index.php, that's where they are. They are there in the vendor directory. Make sense? So next step, because just now I told you about the runners, which is the thing that deals with the return value from the closure, but now we need the argument resolver so that we can provide the correct request object to the closure. So this is, for example, accepting a request from PSR 7 and returning this response. So it's an even smaller application, like a one request response, one control application. This is a PSR 7 runner. And there, so we have the run method that does return or execute the body, echo the body at the bottom. So this is an even simpler handler or runner for PSR 7. So now, how do we deal with that? We deal with that by also implementing another method, which is get argument. So at the bottom there, get argument is going to be provided with some reflection information from the closure. So we do some reflection on the closure, and we give to this function, hey, I want to run a closure, and the closure has one argument, which is a request, a server request interface. Oh, I know how to deal with that. Let's return the correct object for that. So there you can see we have the same stacking mechanism where one runtime can provide and can deal with many different kind of objects. Like this is returning a PSR7 server request from globals, and for Symfony we have also somewhere some code that does request create from globals if the argument is a request from the Symfony HTTP Foundation. So there are many different kind of return value and arguments that are accepted. So that's in the documentation. So this is a console application. So this is your bin console script. The bin console script is like that. We create the kernel, because this is where the configuration starts, and then we wrap the kernel in the console application, and then the runtime component is going to know how to run this console application, and that's it. We can do that even more simple. So this is a one command file. So this is basic. If we want to do a bit more advanced things with a command, we can declare a single command application. So there you see the closure, it accepts a command, which means the runtime knows how to create an empty command. Then we configure the command in the closure, and then we return another closure, which is the actual implementation, so execution logic of the command, right? So this is a single command application. I like that. I don't know about you, but this is clean, this is clear. We split the declaration step and the execution implementation in two different pieces. Since I like it. I don't know about you, but then there is an extensible mechanism to add more types if you want to. So more types means how do I handle another kind of request object, or how do I deal with my kind of kernel or basically type of application. So you do that. So there is a trick. Of course, you can write your own runtime because there is an abstraction and you can then do everything by hand. Or you can leverage the generic runtime, which is going to look at some special namespaces. So there you see, this is PSR HTTP message server request interface. And the convention is to add a namespace before and a suffix. So Symfony Runtime, the thing we want to handle, runtime. And by naming a class like that, the generic runtime is going to auto-discover it. And that's how you can very easily add more types to your application or create packages that just add that, and that's it. So the implementation is very simple. You just create an empty runtime, like the first line, that extends the actual implementation. And same for, so another example there, to deal with responses from PSR namespace. So we extend generic runtime, and there I think we already saw that, so let me move on. What is interesting there is the bottom. You see there is some auto-registration mechanism. So the runtime component will auto-discover this class because of the namespace convention. It is going then to call the register method, and the register method will actually register this type and maybe some sibling types. So this is what we do here. When we discover this type, we also say that, oh, by the way, the runtime implementation for the server request interface and the response interface is this current object, right? So that's an extensibility mechanism that is built in to make this very easy then. You might wonder how many runtimes might need to be written. Not many, actually, because there are two things that drive the creation of a new runtime. One is the infrastructure side. So traditional web server need a special way to be told how to receive or send responses. Then same for edge-side computing that Kevin mentioned, AWS, Google Cloud, or runtime with ReactPHP, Roadrunner, Swoole. Then on the other side, we have applications like basic PHP application or Symfony HTTP Foundation-based applications or PSR something applications, console application, and then you create a mix of that and you have 30 runtimes, and Tobias wrote them all already, so you don't have anything to do. So thank you, Tobias, for that. Short technical focus, how did we solve this challenge, getting the return value? So this is, yes, this is on the top, your script, right? So we require the autoload runtime script, and we return a closure, whatever the closure. So this is at the bottom, so yeah. Then let's execute that. First, we execute the first line. So require once, we enter the autoload runtime script. This one is going to require the autoload.php file from autoloader, from composer, obvious. Then we are going to require script file name, which is public index.php. So we are now going to require the thing that required us. And of course, we do that because we can then read the return value from that. So we are back to the next line. And we have app that is populated, and we can continue. So we expect that it's an object. If it's not, we continue. And then let's continue. We have this runtime, because we need to create the execution unit. So this is an object. So first, we have this class, which is configurable. As you can see, the runtime is this environment variable I showed you on the previous slide. And so we create this runtime object. We configure it a bit. So then we call getResolver, which is the thing that knows how to compute the arguments of the closure. Then we run the closure with its arguments. And then we exit the script by calling the runner. And that's it, right? Easy. So you can configure also the runtimes, because runtimes might have some options that you might want to set to tweak them. So to configure a runtime, you would use the composer.json file. So in composer.json extra runtime, there you can put like the class, and this is going to replace the environment variable I showed you before. You can also put many other values. It depends then on your runtime and what you want it to do. So the generic runtime already has some options. You might want to have a look there. Because we changed the class, the autoload runtime.php script is a bit different now. As you can see, we have the two options that have been dumped into it. So this is because the runtime component is hooking as a composer plugin. So when you run composer, there is some logic that is generating this file. This is not mandatory. If you don't like composer plugins, you can just commit this file and tweak it to your needs. But this is just convenient, right? And that's it. So the runtime interface looks like that. That's the core of the component, the most complex things we had to discuss for months, like two abstract methods. So getResolver, that returns a resolver interface, and getRunner, that returns a runner interface. And there is the generic runtime implementation. So how this works in a more abstract way, there are 5 critical steps. And the nice thing of those steps is that you can hook in between or between and before and after each step. So you can decorate any of those steps to make something fancy that you want to make at the runtime level. So that's why this is flexible. That's because you can control how each step behaves. So first, your front controller returns a closure. Then we resolve the arguments of the closure. So if you decorate that, you can maybe decorate the arguments themselves if you want to, etc. Then we call the closure, but maybe you decorated the closure itself. You can do that, of course. Then the return value of the closure, like the Symfony kernel, is passed to some runner. So you can also hook there so that you can maybe add the HTTP cache on top of the Symfony kernel if you want to. So then you have a runtime that has some caching built in. And then there is this exit code that stops the PHP engine usually, or would tell some Swoole runtime how the request went if you want to deal with the exit status in a different way. You are not going to exit from that. Okay? So that's super flexible. So small side note about Laravel. You might have heard about Laravel Octane. Laravel Octane is about running Laravel on Swoole or on a Roadrunner. This is very different from Symfony Runtime. It's different because it's tightly coupled to Laravel. If you look there, you might have a hard time adding more runtimes, and you might having a hard time using that for something else than Laravel. So it's tightly coupled, and the comparison stops here. Basically, it's completely different, even if you can achieve something similar with Symfony Runtime. You can extend that in Symfony. So as a conclusion, this is from Tobias. So I'm joining Tobias. This is a wish. And the wish is that in 2022, we might all abstract the file system, because we run things, in containers, and we want to be able to write on S3 instead of writing on the file system, or actually want to be able to swap this kind of storage with however we want. So we would use fly system, I suppose, for everything related to storing uploads and things like that. Then we would use Redis memcache for session, caching, things like that. Again, to have a scalable design, architecture, infrastructure, very fast, and not needing any writable storage, right? And shared automatically, clustering, etc. We should not use super globals, because that's the beginning of, nightmares. And maybe you do that, so that's cool. But maybe you still have some progress, and the Symfony Runtime component might help on this path, telling you what we could do, or what you could do as an experimentation is write a runtime. That's an idea. I didn't try it, but write a runtime that kills the superglobals at the bootstrap of the application. You might want to create a runtime that empties all the superglobals, so that then any code that tries to read that fails. If you want to do that, then you are sure that you'll achieve this decoupling from superglobals. And the wish is that also every single PHP application would use the runtime component to get all the benefits of that I mentioned before. So Symfony Runtime is used by default since Symfony 5.3. It makes you ready for swapping the infrastructure. That's the point. That's one point. Swapping the infrastructure, computing on the edge, using Swoole, using development, using PHP-FPM, etc. It opens up innovation at the infrastructure level. So now people that like hacking Swoole, Runtime, React, they can do work there. I'm sure there is some innovation that can happen there, like instrumentation, like, I don't know, like emptying the superglobals. We can try that without titling these experimentations to the applications themselves. And this shouldn't be your daily working layer. I'm not telling you something that you are going to use tomorrow, because you're still going to work inside API platform, inside the Symfony, and then usually the application is already bootstrapped. But you should know that there are still people that are going to push that, like Kevin maybe, so that then it runs seamlessly, and you can swap the infrastructure for seamlessly. So of course, I'd be happy to listen to your ideas of what things we could do at the infrastructure runtime level, but usually you won't hack there. That's not the place to hack too much. Thank you very much. I hope this was kind of inspiring, and if you have any question, let me know.
Thank you very much, Nicolas. Are there any questions online or on site? Okay, we have 2 hands there. So, okay, let's first with you. Are there any questions online too for the next? No question online, okay.
Oh, thanks for your talk. I really like the idea of swappable runtime. I think it's very promising, as you said. My question is, every runtime is providing global state through the context variable. How can you extend, if you want to add more metadata or variable to expose more things to the context variable? How do you do?
So You would create a runtime. Because it's very easy to create a runtime. Runtimes with this interface, there are two methods. You can decorate the generic runtime from Symfony, and that's it. So you would create a class in your application that does this extra logic, and then you would reference that in either the composer JSON file or some environment variables, depending on how you want to make that work, and that's it. So you don't have to use the context variable because the context can be also provided through an object, like a Symfony request object, for example, or, yeah, that's start. Or your own domain object if you want to bootstrap with some context object, maybe.
Thank you.
I think we had an extra question there. Quentin. Pardon, juste ici.
Thank you, Nico. I really like it, especially the hack on the, hey, I require myself back. So just to be sure, so that works only because it's required once, and we do the die at the end, right? That's the first thing, okay. And my question was more on the runtime implementations. I actually forgot the terms you were using, but you can have like suggest to just do your implementation extends the generic runtime.
Yes.
Why is that actually rather than more like adapter, kind of like you support this this input and then you provide something? Why this extension? You need to extend the class.
Why do we need to extend the class?
Yeah, exactly.
Because that's the way things are registered as a single unit. So you can create several in the inheritance tree. You can create many different runtimes, but at the end, they are all going to be wrapped into this generic runtime that is going to dispatch to the correct runtime. So, right, it feels like there is a decorated runtime from the outside, but actually there is one generic runtime object that internally deals with many dedicated runtimes, and it is dispatching that depending on the type of the argument or the return value. Does that make sense?
Not yet. Fine, thank you.
We might talk about that after.
Any more questions? So do we have? Oh, we have a question online first. Sorry.
A question from Jeremy. How much performance benefit can we get jumping from a container as a service approach to a function as a service like Lambda for Symfony?
I don't know. 0. Yeah, 0, that's the same. There is the same logic that needs to be run every time. So 0. You would get a benefit from Swoole or ReactPHP, like long-running processes. But otherwise, you have to boot the kernel, you have to boot the container. So 0, I think. Sorry.
Okay, we had one last question there.
Thanks for this talk. I've seen this component and now it's like taking real shape now with this conference, so thank you for presenting it. I had a question regarding functional testing, and I was wondering if it was possible to use such features such as like creating the kernel one single time and reuse it on every test while running PHP unit, for instance, in order to somehow save performances, maybe, because it seems like the kernel is capable of resetting itself. But I was wondering whether we could like keep the cache in the memory, so it doesn't have to reload the cache on every test.
Yeah,
so
that's a good question. So right now we create a new kernel every time, with some magic inside Symfony. So I think that would be very interesting to explore. Being able to use the front controller inside our test, which would return this kernel object, and then we would be able to run it into tests. I didn't think about that, but that's why I mentioned it opens innovation at the infrastructure level. I think this is one really nice use case of being able to get back this kernel. This is something you cannot do right now. You cannot get your kernel, the real kernel for testing. We need to have some very strange way.
We would need to create it statically on every test case creation, for example, with this setup before class or something like that. Or even have it globally with the bootstrap
you
script.
would require the public index.php file.
Yeah, with the runtime, yes. But actually, with the current setup in the PHP init web test case, you would need some kind of
Yeah, there is some.
variable
I don't
or
like the
something.
code. When I open this class in the test kernel testing framework of Symfony, it's a bit scary. It works, but so I'm waiting for a pull request.
Thank you very much.
Thank you.